Okay, in this lab we're going to figure out how we can identify from an unknown 4 different compounds that we're working with. And let's say we know we're dealing with compounds that have carbonate or hydrogen carbonate in them. The lab makes a very distinct difference between what is a hydrogen carbonate, and that is these particular compounds right here, the sodium hydrogen carbonate and the potassium hydrogen carbonate. Then it differentiates by name and says these are carbonates here. So we'll address this for the first question for the advanced study assignment. Okay, so the way that we're going to be able to do this is using a balance, and this is how much of the work was done for chemistry with guys like Antoine Lavoisier and others like Dalton, who basically had a balance, and they were able to determine what they had using mass differences in their understanding of molar masses and changes in that. So what you're going to do for the first step is take your unknown, and you don't know if it's one of these 4, but it'll be one of these 4, and you're going to heat it. Now carbonates won't change, and there'll be no mass difference. Well, there actually may be a little mass difference, because you guys are probably looking for if it changed by 1 milligram, there's a mass difference. But what we're looking for is if there's a greater than 10% mass change, then you will have had a hydrogen carbonate as your original sample. So that means you now are down to having either sodium hydrogen carbonate if there was a big mass change, or potassium hydrogen carbonate. Well, how do you know what you have? And that's the goal of the lab, is to figure out whether you have the sodium or the potassium. Okay, so you've done a conversion. Now according to equation 1, the chemical equation that's there, 2 moles of sodium hydrogen carbonate become 1 mole of sodium carbonate. So now in the container you have sodium carbonate. Now you're going to add hydrochloric acid, and you're going to convert this sodium carbonate into a chloride. The hydrochloric acid will react with the carbonate ion, and it will leave and create water and CO2, and some chloride will be remaining. That chloride will interact and form an ionic compound with the sodium. Okay, and so now you have a chloride. According to equation 2, though, 1 mole of sodium carbonate becomes 2 moles of sodium chloride. But if you look at the original and overall, which means by adding the 2 reactions, you'll see that 2 moles of your hydrogen carbonate became 2 moles of your sodium chloride. So in essence, it's a 1-to-1 mole conversion. 2 moles make 2 moles, or 1 mole makes 1 mole. Either way you want to look at it. So what the lab is saying, hey, if I think about the mass change that took place here with the sodium salt, I can do something that says Q, which means I take the mass of the original amount. Let's say you had 84 grams. This is a theoretical calculation. And then I subtract off the chloride that was made. Then I divide it by the original weight. This number will look different for the sodium salt versus a Q that you would get if you did it with the potassium salt. They'll give you different numbers. If you're using potassium, then these numbers here will change, and you must go through and figure out what those might be in theory. Okay? So this Q at the end is based on the mass change. Well, if you think about it, if you had an equal amount of a sodium carbonate and a potassium carbonate, when you convert it into a chloride, you're going to see a bigger change because, or a different change, because sodium weighs differently than potassium. And so this is just a mathematical way to see the change, sort of like a percentage. Okay? Well, that's one way to think of it if you had a hydrogen carbonate, but if your original sample was a carbonate, then you'd see really no mass change to take place here. Now you may see a little bit, okay? So less than 10% is okay, and you have a carbonate. Well, you're going to do the same thing. You add hydrochloric acid, they'll convert everything into a chloride, but your original carbonate, let's say it was sodium carbonate, produces 2 moles of sodium chloride for every 1 mole of carbonate you had. Or 105.99 grams of sodium carbonate, that's the molar mass, by the way, hint hint, becomes 2 moles of sodium chloride, and 58.44, if you haven't figured it out by now, is the molar mass of sodium chloride. Well, if you do this Q thing again with 105.99 minus 116.88 divided by the original 105.99, you'll get a Q for the sodium salt if it was a carbonate. So we just have to think about it using equation 2 now. 1 mole gives 2 moles of sodium chloride. So you think about the Q, and then you have to go through and think about what would the Q be if it was a potassium salt. These numbers change because you'd have potassium carbonate, potassium chloride, and so you need to do that. So let's look at the ASA real quick. ASA says, is the sample a carbonate? After you read this information, you have to decide, was there a significant weight change between the original amount and it barely changing to 0.4855 grams. Okay, reason below you need to write in there. So is it a carbonate versus hydrogen carbonate? Okay, that's what it's asking. Carbonate or hydrogen carbonate. And so is it sodium carbonate or is it potassium carbonate? Do you think it's one of these two? If you do, you circle yes. Well, what 2 compounds might be in the unknown? Well, if you think it's a carbonate, it's going to be sodium carbonate or potassium carbonate. Now you're down to those 2. If you think it's a hydrogen carbonate, then it's going to be sodium hydrogen carbonate or potassium hydrogen carbonate. And then here, you're going to either need to write down reaction 2 if it's a carbonate, or you're going to need to add reactions 1 and 2. And my hint is, if you have to add reactions, see what can cancel out that is both on the product side and the reactant side from equation 1 and equation 2. And the hint there, it's sodium carbonate, you'll see, is on the product side of equation 1 and the reactant side of equation 2, and those 2 things will cancel out. Okay? And then this is talking you through what I just went through on the previous slide. How many moles of chloride would you get from the original amount? Think of it from a moles, so it's going to be probably 1 or 2 moles depending on what you had there. This is asking for the molar masses that you need to write in, and I'll give you one here to get started with. If I wrote down the right one, oops, that is not the case here. Erase that. This one is actually 84.01, and this was the 105.99 that I was working through in some examples here, and the 58.44. So I guess I saved you a little time. So what you got to think through is those original amounts. I just used the mole amounts here. If you had a sodium salt, let's say sodium carbonate, just use 105.99 grams. How many grams of chloride would it give? Refer to my previous slide. Okay, and then you have to think through, oh, what was the potassium salts? What would those be? Then use equation 3, or was that little ratio that I used to find Q. What would it be in theory? Okay, these are the theoretical values right there. They tell you about that. And then you need to decide. Okay, here's theory. Now you need to take the observed value of Q. Well, you need to take the original amount, okay, which was 0.8462. You minus the weight of the chloride, and that they give you, okay, 5247, and my bad handwriting here, divide by the original weight, which it was given. And you see your EQ is, and you compare them here. And then you've got to try to decide which one it is. Hopefully that gives you a little better attempt at what it is. This is what you can do in the lab. This is exactly everything you're going to do in the lab, and these cues will actually help you So hopefully you take some good notes here, and hopefully this makes a little bit better sense. We're just using a Bunsen burner, and we're using the balance, and we're going to be able to determine which one of the 4 unknowns you have. So that's pretty cool. You can tell whether it's a hydrogen carbonate or carbonate, and then you can tell what cation you had, sodium or potassium.